For this problem, we're given a ladder 12 feet tall. It weighs 40 pounds, and it's leaning against a frictionless vertical wall. The lower end of our ladder rests on a rough ground. It's 4 feet away from the wall. So we know the length of the ladder, the distance from the base, so we can calculate the height. We're given that the wall, the vertical wall, is frictionless. And we know that because it is frictionless, the wall won't sustain a reaction in the up and down direction. It will simply give us a reaction that is horizontal at point A. So we have A here. Now, at the base where I have B, I'm told it's a rough surface. A rough surface can sustain a force in the X and Y direction here. So we know that we have a force that is on an incline. So let's, we won't do BX, BY. We're just simply going to draw a rough reaction here that has a little bit of an X component and a little bit of a Y component. We'll just label this B. And then, of course, our weight is acting at the center of our 12-foot ladder. So we know that if we do the geometry, that it'll be in the center. And so this distance, the horizontal distance to the end of the ladder, will be 2 feet. So knowing that, we can, well, first off, we have the geometry. So we can solve for the height from C to A. So we know that from Pythagorean's theorem that, call this h squared plus our 4 foot squared equals our 12 foot squared. We know that h squared equals 144 feet squared minus 16 feet squared, or h equals square root of 128, and that is 11.3137 feet. So we've solved for h. So h equals 11.3137. And now let's look at our free body diagram. So we know that the weight is 40 pounds, and the 40 pounds is going to be acting in the center of our ladder. We know that we have a reaction at A. Let's just get our ladder sketched in. A. So we have a force there. At B, we have a force that has a component in the X and Y direction. And then our weight is acting right in the center. That is our 40 pounds. And we also know that the line of action B, for this to be an equilibrium, is going to pass through D, where A and W meet. So if we extend our A and our W, define that as point D, we know that B is going to pass through that point. So given that, let's solve, first off, for this angle in here. All right, so we'll call that theta. And we know the distance here is 2 feet. It's 2 feet here. And of course, we have our vertical length here. That is the 11.37. So this is 11.3137. This is 2 feet. We know the tangent of theta. equals 2 feet over 11.3137. And that is 0.17677. And do the inverse tangent. We'll find theta equals 10 degrees. So that's 10 degrees. And now to solve for the reaction A and the reaction B, we'll use a force triangle. So we're going to start by sketching A. This is A. A is going to be to the right, opposing the weight or the leaning ladder. And then we have our weight, our 40 pounds, which is a straight vertical weight. £40. And then we have a reaction at B, where we have our rough surface. So we created our force triangle. We put the vectors arrowhead tip to the end, and we close it up. We're in equilibrium. So we know that we have 40 pounds here. We know that this angle here is 10 degrees. We know that for A, the tangent 10 degrees will equal A over 40. So A equals our 40 pounds times tangent of 10 degrees equals 40 pounds times A equals 7.07 pounds. And that is vertical. So that is because the wall is frictionless, it can't sustain a reaction in the y direction. So it's simply in the x direction. And then to solve for B, we can use Pythagorean's theorem because we've solved for A and B. And we can say that B squared equals our 40 pounds squared plus 7.07 pounds squared. B equals the square root of, that'll be 1,600 pounds squared plus 49.9849 pounds squared, square root of 1,649.9849 pounds squared, or B equals 40.69 pounds. And then we can solve for the direction because we know that this is a right triangle here. The sum of the included angles for any triangle is 180 degrees. We have 90 and 10. It's 100. 180 less 10. And the 90, that means this angle here has to be 80 degrees. So we know that B is 80 degrees off of the horizontal. So we've solved for our reactions at A and at B.